Now in this video lecture, we will see the performance. So performance is nothing but how the computer is executing the program quickly. It is we are trying to measure the speed of the system. Now speed will be depend on the hardware design, computer hardware design. So to improve the performance, it is necessary to design a compiler, the machine instruction set and hardware in coordinated way. Now here to measure the performance, we have two parameters are there. One is elapsed time and another one is a execution time. Elapsed time is nothing but the total time required for the system to get the data from the input to execute and give the result to the output. Complete all the time from the input to the output device, how much time it is taking, that is called as elapsed time. And another parameter is execution time. Execution time of means the processor fetching the data from the main memory and executing how much time it is taking to execute the program, that is called as the execution time and that is represented by the t. Now generally this performance can be improved. Now this is the processor. Whenever you write the program will be stored into the secondary memory. Whenever you try to execute, that will be copied into the main memory. So program is a set of instructions, so one after the other instruction will be fetched from the main memory and the processor will execute in the processor. So in the ALU. So for that, now here if the processor is going to execute instruction, it will go to the main memory and fetch the data and execute in the ALU. So every time going to the main memory and getting that information means it takes some time. So instead of that, if we introduce a cache memory is nothing but what it is a semiconductor memory which is very high, very speed and capacity is very less. So whenever processor fetch the information from the main memory, that is copied into the cache memory. So if the second time the processor need the same data, it will get the data from the cache memory. If the data is not available, then only it will go to the main memory. Thereby, the fetching time is reduced. If the fetching time is reduced means the overall execution time is also reduced. Thereby, we can improve the system performance. This is one way how can we improve the performance of the system by introducing the cache memory within the processor. Now, we will see how to calculate this execution time t. So for that, let me explain few terminologies like a clock rate and a clock cycle. So clock, now any digital devices, now here the system is also one of the digital device. The processor circuits are controlled by the timing signals called as clock. Now here you can see this is nothing but a clock. And now in this, from this is one on time and one off time. Both together is, it is called as a one clock cycle. And this length will be represented by the P, and the reciprocal of this clock cycle is called as a clock rate, and this clock rate is represented by the capital R, and the units for that is hertz. So this clock rate also we can call it as a frequency. And each and every instruction will be divided into some basic steps. So each basic step will be executed in a single clock. Now if the program is having 10 instructions, now each instruction will be divided into some basic steps. Now for example, here I'll say three basic steps. One is fetch and another one is decode and another one is execution. Here I'm taking three, but it is not mandatory that every system should have the same steps. System to system, it will vary. But for easy analysis, I'm saying that instruction will be divided into three basic steps. One is fetching, and another one is decoding, and another one is execution. Now, T is the total process time required to execute one program. And in that, N is the number of instructions to be executed. Now here the n is different from what we have written in the program. So in the program, sometimes we may write a more number of instruction, but all those instructions we may not execute. Why? Because if you use some conditional statement, and sometimes we write the less number of instruction, but we execute more number of instruction if you write loop. So that's why here n is not a written instruction, n is a executed instruction. Now s is, just now we have discussed basic steps needed to execute one instruction, and R is the clock rate. Just now we have discussed it is a reciprocal of the clock cycle. Now to calculate T, the total execution time required T is equal to N into S divided by T, where N is the number of instruction into number of basic steps involved for the instruction. Now, for example, if 10 instructions are there and each instruction is taking the average number of basic steps are 3, then N into S is equal to 30, and R is the clock rate. Clock rate is nothing but a frequency. So for system to system, this clock rate will change. Now in this, if this is the performance equation, then how to improve the T? How to improve means what? How to reduce the execution time, thereby improving the system speed. Now, by introducing the first concept is by introducing the pipeline and scalar, super scalar operation. Pipeline is nothing but, so now here, just now we have discussed each instruction is divided into basic steps, I said, right? Now here, if you take, now this is the uh, program which is having 10 instructions. Now the first one is fetching, fetching. The second one is decoding, and the third one is executing. Now, for the first instruction, now these basic steps are common for all the instruction. Now the first instruction is fetched from the memory. While it is decoded, that time the second instruction is being fetched from the memory. And when the first instruction is execution is taking place, the second instruction decoding and the third instruction fetching is taking place. So with this, what happens if more number of instructions are there, more than 3 instructions are there, from the third instruction onwards, it will take a single clock pulse to execute. So what, by you introducing the pipeline is nothing but what? Parallelly, we are executing the basic steps. So instead of executing one after the other sequentially, we are executing parallelly. So thereby the S value, we are reducing it to 1. Now from the third instruction onwards, the number of clock cycles required to execute the basic steps is only 1. So thereby we can reduce the N into S, the product of NS. So like that, we can improve the system speed. And another one is a superscalar operation. Superscalar operation is nothing but introducing the multiple functional units. Now to execute here, instead of having one ALU unit, if we have a multiple functional unit, so depending upon which instruction we need to execute, we can send that instruction into that particular functional unit. Thereby what? We are executing the um, more than one instructions parallelly. So thereby we can achieve S should be less than 1. So with that, we can reduce the overall product, N into S product, NS. So thereby we can reduce the time required to execute the program. So this is one method. And another method, already we have discussed that T is equal to N into S by R. So that S we can reduce by using the pipeline concept and also superscalar operation. Now, if we can improve the R, if we can improve the clock rate, then the N will be, T will be reduced. That can be done by that can be done by introducing the integrated circuit technology, IC technology, to make the circuit faster. To make the circuit faster means what? Propagation delay will be very less. Means what? When we give the input, to get the output, it will take less time. Thereby what? The clock length to execute the basic step will be less. Thereby the clock rate will be increased. So another method is risk and risk. Now here this is the instruction set. By choosing the proper instruction set, we can also reduce the N into S. So reduced instruction set risk and complex instruction set risk. Reduced instruction set means what? Here we need a less number of instructions to write the program. But complex instruction set means what? We need more number of instructions to write the program. Here, less number of instructions means what? N is reduced in the RISC system. But if a number of instructions are reduced means what? The basic steps involved in the instruction to execute one instruction will be increased. So in a RISC, N is reduced, but S is increasing. In the CISC, N is increased, but S will be reduced. So we have to choose the proper instruction set. Now, if I choose the RISC along with the pipeline concept, already we have seen the pipeline concept. If we use the pipeline concept, we can achieve the S is equal to 1. Now, by taking, though the basic number of steps are increasing in a RISC, but by introducing the pipeline concept, we can achieve S is equal to 1. If the number of instructions are less, then overall the T is equal to reduced. Now, next one is a compiler. Now, compiler is which translate the high level language program into the machine level language program. Now we have to choose our goal is to reduce the n into s. Now we have to choose the compiler such that which now we have to choose the compiler which reduce the n into s. Now few compilers are rearrange the program instructions to achieve the better performance. Such change must not affect the result of the computation. Now the last topic is basic performance measure. Now till now we have studied about the T, how to improve the system performance by measuring the T we have seen. But it is very difficult to measure the T because T involves the hardware. The same performance equation we can't apply for all the systems because different systems are having the different functional units and different architecture and different instruction set. So it is very difficult to measure the T. So instead of measuring T, there is another method to measure the performance of the system, that is by running the benchmark programs. These benchmark programs are published by the SPEC. SPEC is the System Performance Evaluation Corporation, which publishes the programs which are earlier they used to publish the artificial programs, but now they are publishing the real-time programs in different domains. So if this program is run in the reference computer and as well as computer under test. Now whoever manufacturing the computers, they will run the program in a reference program and a program computer under the test. So they will take the ratio of this. That ratio is called as a spec rating, and the spec rating is equal is nothing but a ratio of running time on the reference computer to the running time on the computer under test. Now whatever the ratio we are getting, this is for only one program. Now such a program, if n number of programs we are running, then this is a formula we need to use. Spec rate is equal to pi I is equal to 1 to n spec I whole to the power of 1 by n. Now by calculating this, we can calculate the spec rate. Spec rate is nothing but a measure system performance. So like this, we can measure the performance of the system. So with this, we have finished the today's topic.